So now let's use source transformations to simplify a circuit in order to find a voltage and a current. So source transformations are based upon equivalence. And what equivalence means is that if you have a voltage source in series with a resistor and you use a voltmeter or an ammeter or an ohm meter to measure the voltage, the current, or the resistance across those terminals, then there's another circuit that will give you equivalent readings across those same terminals. And that equivalent circuit is a current source in parallel with a resistor. And this is where we get source transformations from. So no matter whether I have the circuit on the left or the circuit on the right, if I put a voltmeter, an ammeter, and an ohm meter across those terminals, they would read the same voltage and resistance. And the way that that happens is that if V is equal to I times R, which we know is Ohm's law. So as long as the value of this current source is V over R, or the value of this voltage source is I times R, and both of these resistors are the same, then these two are equivalent circuits. And when you convert between them, that is called a source transformation. So when you have a voltage source in series with a resistor, you can change it to a current source in parallel with a resistor as long as you use these values. So now that we know that theory, we're going to use it on this circuit up here. So up here, I have a 10-volt source in series with a 5 ohm resistor. So I can change that to a current source in parallel with a 5 ohm resistor. And the value of that current source would be 10 divided by 5, which is 2 amps. And then I have the 5 ohms in parallel with 20 ohms. And then that's in parallel with 1 amp. So there's more to the circuit, but I don't need to draw that part next because I am now going to combine all of this. And what you'll have is 2 plus 1 is a net 3 amps pointing up. That's based upon Kirchhoff's current law, that the current into that top node is 2 amps from the left, 1 amp from the right. So that's a net 3 amps coming into the node from the two current sources. And then here, I'm going to have 20 in parallel with 5. That's the same as 20 times 5 over 20 plus 5, which is 100 divided by 25. So this is 4 ohms. So now that I have that, I'm now going to add back on that last part of the circuit. And remember, the benefit of doing this is I've now simplified the circuit enough so that it's easier now for me to find Vx and Ix, which are the voltage across and the current through this 4 ohm resistor. Since I have 4 ohms in parallel with 4 ohms, I know that they're going to evenly split the current source. So that means Ix, the current through that 4 ohm resistor, is going to be 1/2 of 3 or 1.5 amps. So this is now a whole lot simpler to analyze than the original circuit. I could also do one more source transformation to find the voltage. And I would get 3 times 4 is 12 volts in series with 4 ohms and in series with another 4 ohms. And now if I want to find Vx, I can see that since this 4 ohms has to evenly divide 12 volts, then Vx is going to be equal to 1/2 of 12, or Vx is equal to 6 volts.